Hi, in this session we'll discuss about descriptive statistics for numerical variables. So we are going to see about and calculate summary measures, that is central tendency, basically where the center of the data lies, that is mean, median, mode. We are going to discuss the measures of variability, that is variance, standard deviation, basically how your data is spread. Next, we will see percentile and quartile. If I have to see what is the where the 50% of the data, what is the salary, say here we are going to use the salary as a salary variable, which is our continuous variable. And all these univariate analysis we are going to do on this data set. So other than quartiles and percentile, we will check about the shape of the data and through skewness and kurtosis, and we are going to use some charts for seeing this numerical variable like histogram and box and whisker plot. So the learning outcomes from this would be how to explore your data. You will get to see when to use median and when to use mean, and we are going to use Excel functions and analysis tool pack for this analysis. So these are some of the questions that we are going to answer. This is the data set that we have. We have player, team, position, and salary. So the first objective is to calculate the central tendency. So the formula for mean is average, and we will see the data. The data is given here, the salary. We will select this data, hit enter. So this is the mean value. Similarly, we can calculate the median of salary, and similarly mode of salaries data set. So when you see this mean, median, and mode, you would see that the difference between mean and median, there's a huge difference between mean and median. And why this is happening? This is because our data may be more skewed. And when the data is skewed, this means we have some of the players who have very high value, high salaries, and which is actually shifting my mean. So mean is basically something which gets changed and gets affected by high values, so or say extreme values. And this is the reason that I have a very much, there's a difference between mean and median. So because of these high salaries, maybe because of these high salaries, the mean has shifted, and that's why we are seeing this difference. So it is giving us initial inspection, as in whether the data is skewed or not, though we are going to check this through the measures of shape. Say if I check the shape, that is whether my data is skewed or not, I can use skew function and then check this data set. And this skew is positive, which means that my data is positively skewed. We'll come on that positively skewed, as in how the data looks when it is positively skewed. And when it's positively skewed, then your mean is higher than median, and then in that case median is a much better way of summarizing the value, the data. Let's see what is the minimum value and maximum value, because range is also a measure of variability. So let's see what is the minimum value. Let's see how the data is, as in like how the salary varies. So this is the minimum value, and what I can do is I can just make this as absolute, say using 4 second. This is absolute, and like I calculated minimum, I can also calculate the maximum, that is 3,20,000 something, a very big value. So we can see the minimum value and the maximum value. So some of the players have very high salaries, but it's not the case with most of them. So because there is a huge difference between maximum and minimum, that's why there is going to be a huge range. What is this interquartile range? So let's see what is this percentile. So basically percentile is, say if I ask like what is 1 percentile. So percentile is basically how many percent of the values are below it. For example, if I ask what is 1 percentile, so 1% of the values are below then this value which we are going to calculate. So how to calculate it? So you can go to percentile. So this is returns the kth percentile of values in a range where k is in the range. And so what is the array? So array is my salary, and because I'm calculating 1 percentile, so it's 0.01. Similarly, I can calculate it for all these percentile. What I need to do is I am dragging it here, and then I can just simply say change it, or just can also give a reference also. So this is 0.1. 0.1, basically 10 percentile, then it is 0.2, that is 20 percentile. And what is this 50 percentile? So 50 percentile basically is nothing but is, when you divide the data into two parts, that is your median. See this value and this value, it should be same, it should come same. So okay, so this is because there is error in the data, error in the formula. So if I make it absolute, and then I need to, or just I can copy paste it like that. So you'll have like 75,000. Now it is correct. So this is a 80 percentile, 0.8, 0.9, that is 90 percentile. Similarly 0.95, this 0.95 and 0.99. And now I have to calculate the quartile. So quartile is basically you are dividing the data into 4 parts. So say this is your whole data set, and then you are dividing it. Say this one is first quartile, like that is a 1/4 or first fourth of data, then second quartile, and say this is the third quartile. So basically this is 1/4, say 25% of the data, and then this is next 25% you are adding, that is your 3% of the data. Now this quartile to 50% of the data is also called median, and the difference between this quartile 1 and quartile 3. So basically the difference between Q1 and Q3, this data. So if you remove lower 25% and higher 25%, the major chunk that is between Q1 to Q3, that is your interquartile range. So let's calculate what is this quartile Q1, Q2 and Q3. Let's remove this. So Q1 is, so you have this formula for quartile. We select the array. So array is the base, same thing, that is the salary. And for quartile, if I say, see here it is first quartile, that is 25th percentile. So till $4,30,325, that is the first fourth, like 25% of the data is below 4,30,325. Similarly, the next 50% of the data, say half of the data, basically this second quartile. So what I can do is just make this absolute and just make the changes in the formula part quickly. So quartile 2, that is 50%, that is median value. And then this third quartile, that is another 25%. Quartile means 25%. So 50 plus 25, that is 75%. That is the third quartile. So if I want to understand what is this interquartile range, like we discussed, is Q3 minus Q1. So this value minus this value, first quartile, that is my interquartile range. And what is the variance? So there is a formula for variance. You can calculate for population and sample. It's not going to be much of a difference. If I say start with the variance of population, and then I can take this. What is the standard derivation? It is simply the square root of variance, and we are seeing from the from variance that it is coming in exponential. Basically, there is a lot of dispersion in this data, and we have seen this in maximum minimum value as well. You can also calculate the percentages of value which is less than given value. For example, if I want to calculate, so you can use it using COUNTIF. To include a formula, I need to use COUNTIF equal to COUNTIF. So the range of this data set, the same range, and then I have to see that it should be, say, equal to 1 lakh, or say less than 1 lakh. Say here I'm calculating, which is less than 1 lakh, not 1 lakh, actually 10 lakhs, so it is in dollars. And close bracket, I can put it in commas. So okay, there's a problem. Okay, so maybe this, I can do this. So count if this value is less than this value, and similarly we can do it for other values. So basically it is telling that, say, this much of percentage, 843 is the total number, so 46 percentage of the data has salary less than this, that is around 10 lakh. So accordingly you can calculate these values. Other than that, what we can do is we can see create this histogram. Now how to create this histogram? So you can calculate what is the minimum value, what is the maximum value, what is the range, and that is maximum minus minimum. After that you can calculate levels is something that we are going to take ourselves. Say if I take 11 as levels, and the width is basically your range divided by this range divided by your width. And when we do that, we can create this upper bin and lower bin. So I already have calculated it here. So if you see this, yeah, so this is minimum, this is maximum. So this is the minimum formula, maximum levels and range, minimum maximum minus minimum, and this is the width, that is the range divided by 11, because I have taken, say, 11 levels. The lower bin is basically your lowest number, that is your minimum number, and upper bin is basically what you are doing is adding your width, this, in your lower bin, and just drag it. This is how you can create the frequency distribution. Frequency I have calculated using this frequency formula, and for this the input is your data, that is salaries data, and the second input is your bin array. So bin array is basically your upper bin array, and here you can calculate this. You can create this histogram, by using analysis toolpath. So you go to data and go to data analysis. Here you can go to histogram, click OK. So the input range is basically where the data is lying. So salaries data is here, so select salary, control shift down. Bin range is basically your upper bin, so this upper bin there. Tick labels because we included labels while selecting the data and bin range. Output range, say if I want to create it in a different worksheet, keep it like this only. If you want to create it in output range, so you have to select this and give it a cell reference wherein you want that your histogram output to be plotted, and then chart output and hit OK. So this is how this will come out. This is upper bin, this is the frequency. Now this histogram is not looking like histogram, so what you can do is, because basically it's a continuous data on which we chart histogram, and ideally it should not have any space between it, so we can change it from quick layout like the one I did, and then you can resize it. Let's make it bigger so that we can see how the data is looking. If you see this data, this is positively skewed, and we saw that while calculating the skewness also here, so it is positive here also. We also have median lower than mean, and this is how the histogram will look if the data is positively skewed, and we are seeing that median is lower than mean, skew is also positive, and this is how the data is. So it's not a normal distribution curve, but is a more of a positively skewed data. So in the session we covered central tendencies, that is mean, median, mode. Percentile, that how your data is divided. Say if I want to see that 25% of all the values are lying between which are less than which salary value, I can calculate it using percentile. I can also see where the 25, that is quartile. So the whole data is divided into 4 parts by 3 quartiles, Q1, Q2, Q3. Q1 is your 25% of the data, Q2 is your 50% of the data, which is also called the median value, and that's why we have the value of Q2 as 50% and the median value as same. When we are seeing mean, median and mode and trying to identify whether to take mean or whether to take median, and we saw that because the data is skewed, it's better to go with median, because mean is coming because of the extreme values in the salaries. So some of the players have extreme values, and that's why our mean has shifted. We can also see the mode, but mode is not doesn't give a good picture when you are working with the continuous data. So this is how you can do the descriptive analysis and also visualize your data using histogram. That's all. And other than that, yeah, you can also create this box plot. So for that, just go to insert, and here in charts you can go to box and whisker plot, and here in select data, select the data, that is salaries data set. So shift it, and this is the salaries data set. Okay, and this is the box plot. So what this box plot is telling you, so this cross is basically telling me the mean, and this box is basically, this extends from first quartile to third quartile, and these data points, these points are basically your outliers. So we are seeing a lot of outliers here, and this is like this is a outlier that extends to like very far. It is like highest, and see that how the data is dispersed. So box plot gives us the idea, and this is the reason why we have this difference between median and mean, because our data is spread out, it has a lot of outliers, and that's why this is what we can see in box plot. So that was all in descriptive statistics. Thank you.